for Small Businesses That Are Fast and Effective by David Byers. Please join me in welcoming him. And over to you, David.
Hi, everyone can hear me fine. Just give me a quick thumbs up. And everyone can see my screen. Great. All right. So when I gave this session at CF Summit in Las Vegas, it took just about an hour. So I'm going to try and trim some of that fat on the way here. Of course, we're being recorded. So if you need to go back at any point, you can go back and check out whatever you missed. I also have all of the slides and presentation information available on a website, cfsummit.vegas, if you need. There's also a bunch of examples on there that I'll be promoting at the end. So who am I? My name is David Byers. I've been a Cold Fusion developer for 27 years, since February of 1999. I've held multiple CTO and fractional CTO positions. I am owner-operator of CodeMonkey Studios, which is a Cold Fusion development and consulting house. And I'm proof that if you come to CF Summit long enough, eventually they will put you on stage and let you speak. What we're going to cover today, we're going to talk about the problem. Why CI/CD? Why now? We're going to all get on the same page with a lot of the vernacular that's around it. We're going to talk about repository platforms, CI/CD tools and pipelines. We're going to talk about environments. We'll be discussing development strategies and some basic examples. So the problem, why CI/CD? Why now? Now, obviously, it's hard to do a quick poll on an online system, but at CF Summit in Vegas, I did ask people how many people are developing against production or have developed against production at some point during their careers. And then I said, how many people are currently developing against production? Results from CF Summit in Vegas were around 80% developed against production at some point. Around 25% are developing against production now. So I'm going to assume with this audience, probably very similar. Common development sins. Editing code directly on production servers. Terrible idea. FTPing files directly and hoping that nothing breaks on the server. Not using version control or using Git like it's a filing cabinet. What else? No backups, no rollback plan. Testing it live versus using a development or a staging server. So you have a single source of knowledge and that person happens to be on vacation. These are all things that eventually lead to dangerous processes, lack of safety nets, and knowledge silos, all things that can really cripple an application. What do these cause? Broken sites, customer complaints, lack of faith, no audit trail. Nobody knows who did what. There's fear of touching working code. I've actually heard people say, don't breathe on this code, it's fragile. Loss of time and trust, paralysis. Some people won't do deployments because it's terrifying. Why do companies do this? So here's some of the reasons companies give. And let's face it, these are excuses. We're too small for pipelines. No, you're not. CI/CDs for big teams, big budgets. No, you're not. We don't have time to set that all up. A couple of years ago, I gave a presentation at CF Summit where we set up and installed an AWS pipeline with a Bitbucket repository, including setting up the server and setting up Cold Fusion on it under an hour. So if I can do it in under an hour, you can do it in a weekend, right? It's just easier to edit live. This is true. Any degree of process that you add to your deployment is going to of course, cause overhead. It's going to take more time. And sometimes, as a developer, it's fun to just get your fingers in there and change some stuff. Yeah, don't do that because it's just terrible. A little bit of process can save you a lot of headache. So let's get on the same page here. What is CI/CD? CI, continuous integration. This is automatic testing and integrating the code every time it's committed to your repo. CD could be continuous development, continuous deployment, continuous delivery. It depends on who you talk to, whatever they decide is the D in CD. It's automation, basically, to move your code from your repository to your production server without any manual steps. This is all about automation. It's not just for big companies. It's a reproducible way to ship your code. So what's a repository? I think we all know, but let's get on the same page, make sure we're using the same terms. Your repository, your repo, this is the source of truth for your code. It is the official stuff. It stores all the app's code. There are SaaS hosted Git repositories we all know of, like GitLab, GitHub, and Bitbucket. There are also platform native repos for specific ecosystems. If you're all in on AWS, use AWS repos or Google Cloud or Azure DevOps. They all have their own version of Git in the cloud. What's a pipeline? This is a set of repeatable automated steps that run when you push code. It's a way to be able to formalize the deployment process so that everything works the same way every time, and it reduces so many problems. Here's an example. An example pipeline could be you push to the main branch, it runs some unit tests, it builds a Docker image, it deploys that to a staging server, then it sends a notification to a Slack channel. That's a great pipeline, right? But any pipeline is better than no pipeline. It doesn't have to be all fancy. Even a two-step, you push, it deploys, is valid and useful. CD, this is the act of taking your code, putting it on the environment where it runs. Production staging doesn't matter. This is handing your code the keys to the house and saying, go live over here. You can do it with SFTP. You can do it with Docker containers. You can do it with a CI/CD pipeline trigger deployment, which is what we're going to be focusing on. You can use FTP. I'm sure that someone here is, but it's strongly discouraged. It's 2026. Don't use FTP to update your code. So let's talk about the pipelines, how to automate these without it being super expensive. Purpose of a repository platform. This is to keep track of your code so you're not playing, who did this? Gives you a lot of accountability in your code. It's no more living in fear of the junior developer accidentally saving some weird file to production. These platforms are the launch pad. Once you push code, it's the pipelines themselves that are doing the heavy lifting. TLDR, for GitHub, they have actions, what they call workflows. For GitLab, they call them pipelines. They're broken into stages, jobs, and scripts. Everything's in one place. For Bitbucket pipelines, they use YAML and Docker. It's really simple. It's really reliable. If you're already using Jira and Confluence, everything ties in very nicely. Let's talk about GitHub. This is the 800-pound gorilla. Everybody uses it. They've got free private repos, so cost shouldn't be a big factor, especially if you're a small development house. They do these things called GitHub Actions. You click a button and suddenly you're doing DevOps. Be wary of the marketplace. It's full of templates. Some of them are brilliant. Some of them can cause some problems in your code. So if you're looking for a marketplace solution to be able to plug into your pipeline that you think is going to solve a problem, make sure you do your research on it first. They don't call their CI/CD tools pipelines. They're driven by workflows, which are powered by actions. So the workflow is the pipeline. It's the collection of actions. Okay. And then the action is like a Lego brick. It does one specific thing. All of these pipelines have a similar flow. They all kick off with a trigger. Maybe when you push to a main branch, maybe when you open a pull request, maybe you could do it on a schedule, like a nightly build. You can even do the whole, I'm going to hit this button and that's going to deploy the code to the production servers. Jobs are runners that run in a workflow. Each job runs in a clean environment. They can run in parallel if they're faster or depend on each other, which is safer. Most of the teams that I've worked with do their runner jobs in serial because they want to make sure that this is done before the next thing happens. Some can do it in parallel, but I haven't seen too many. Jobs contain steps. Steps run actions. Each of these actions does something in your code. You can mix pre-built actions with your own scripts if you want. GitHub is very powerful in that regard, and it can create artifacts and results like building, testing, compiling, creating Docker images, deploying, all sorts of fun stuff. If you're a small shop, this is useful because it gives you free minutes for your public refos, good quota for private ones. There's lots of pre-built actions. It's integrated with GitHub, so there's no extra logins. This is a good way to get started. Here's a bunch of features. Pretty much every platform has the same sort of 3-tiered plan. They all have a free plan. They all have a team plan. They all have a premium plan. And this will basically talk about the features of each, what's included, how many runner minutes you have, what's going to cost extra or any overage. There are some downsides to GitHub. You can get into some pretty serious cost if you aren't careful. Moving over to GitLab, they don't try to rebrand their pipelines as workflows or actions. They just call them pipelines. Everything is stored in a GitLab CI.yml file. This is a single YAML file that basically runs everything in your pipeline. Your pipeline has stages and jobs. Same thing with GitHub. There's a trigger. It's when you click the run pipeline button, that pipeline gets split into stages. Those stages run in order. It's all serial. Inside a stage, a job can run in parallel, but the stages themselves are completely serial. Each job is doing the actual grunt work. It can run scripts you define. It executes on their runners. You can use shared runners. I had one company that was hosting their own. And yeah, they spent a lot of time maintaining that. Artifacts and results can come out of a GitLab pipeline, like reports, packages. You could do all sorts of stuff with these. For small shops, this is all in one. All the repos, issues, pipelines, registry. There's less tool sprawl, which is kind of nice. You get unlimited private repos on the free tier. You can do self-hosted. Like I said, you kind of have to know what you're doing if you're doing self-hosted stuff. It's got Docker and Kubernetes integration. And again, here are all the plans and user fees. There's a free plan, a premium plan, an ultimate plan. One thing about GitLab that kind of annoys me is they say, hey, it's $29 a month, billed annually. I can't stand when people do that, but for whatever reason they do. Your CI/CD minutes comes with 400, 10,000 for the premium plan, 50,000 for the ultimate plan. And you may be asking yourself, are there 50,000 minutes in a month? No, there's not. There's like 46,000. What does that mean? If you're running runners in parallel, say you've got 5 runners running and each one takes 2 minutes, you just use 10 minutes in 2 minutes, if that makes any sense. Storage and repos, they do 10 gigs per project. They've got security scanning, code quality, all sorts of stuff. GitLab is really robust. Third, if you're an Atlassian house, Bitbucket, they call them pipelines. They live in a Bitbucket pipelines.yml file. It's really simple. If you want simple, Bitbucket pipelines is the way to go because it's a single YML file. You set it up and it works rock solid every single time. Kicks off on a push. It's really easy. The pipelines are a series of steps. They all run in Docker containers, which means if your code runs in Docker, it'll run in this. Steps run after each other, or you can spread them out if you're trying to get results faster. And you define the staging, test, and production right in that file. So everything is in that one Bitbucket pipeline.yml file. For small shops, Jira integration. If you're already using Jira, everything lives in the same thing. Your Jira, your Confluence, your Bitbucket, it's all, part of the Atlassian family. So if that's what you're using as your project management tool, then it just makes sense to go ahead and do that. Forgive me, gotta take a drink here. They've got free private repos and it's all Docker-based execution. It doesn't overwhelm you with features. It's, like I said, it's solid and it's simple, which is one of the things I like about it. Again, free plan, standard plan, premium plan. Bitbucket definitely are the cheapest user plans. $3 per user per month for the standard plan, $6 per user per month for the premium plan. But their build minutes are a little bit low. You can go above that. It's $10 for another 1,000 minutes if you go over. But honestly, most teams that I've seen, they're not doing builds so frequently that, they end up running over these budgets. They've got lots of features and security admin tools, and that's how they do the scales and costs. So GitHub, flashy, friendly, packed with integrations. GitLab, powerful, all-inclusive, all one platform to run the show. And then Bitbucket, straightforward and dependable. If you like simple, that's definitely the way to go. Let's briefly touch on some of the platform native repositories. Again, AWS has them. They play nicely with all the AWS infrastructure. Google Cloud has them. They play very nicely with all the Google Cloud infrastructure, and Azure has them, and they all play nicely with the Google Cloud or with the Microsoft Azure infrastructure. For Amazon, they don't reinvent Git. They just call it code commit repositories, fully managed private repos in AWS. It's like GitHub, but inside AWS. It's dirt cheap, like a lot of things in Amazon, but obviously the more that you use them, the more the cost can start to pile up. So you got to be careful. The trigger pushing to code commit can trigger events in either AWS code pipeline or code build. Those are all different products that end up doing something with the code, either deploying it to EC2 or Lambda, whatever you point it to. It's deeply tied into the AWS ecosystem, and they use their own runners. You don't have to configure the runners. You wire code commit to AWS services, and they do all the building and deploying. So it's very nice in that you don't have to create the guidelines for the runner to be able to get it to go. It's just, I want to tie this into this EC2 service and push the code to here. Everything works. Useful for small shops because it's seamless with the AWS stack. They've got security baked in. I don't know if you've ever dealt with IAM security before on any of the cloud platforms, but yeah, it can be a nightmare. No repo size limits. It's pay as you go. The downside is that the learning curve is pure AWS. It's powerful, but yeah, there's a lot that you can do with it. Here's the plan and usage fees and the storage limits. I'm going to go through this kind of quickly because I know that this can take some time. There's 2,000 Git requests per month for push and pull per user, but each additional really, really cheap. Unlimited repos for free, deep integration with everything else. So let me give you an example scenario here for cost purposes, because again, this is for small businesses that are very concerned about every penny that they're spending. You got a tiny team, less than 5 devs, you're not pushing that much code. You're going to be able to do this for free. If you're already on AWS, if you got, let's say 10 devs, you're going to be paying $5 per month for the 5 active users. Let's say they use 20 gigs of storage and make 3,000 requests per user, $2 or $3 more. You got a growing team, 20 devs, heavier use. You got 15 build users. If they push and pull a lot, you can expect another $10, $15 a month extra. It's not that bad. Moving over to Google Cloud, they just call them cloud source repos. Google, honestly, I feel like Google kind of said, yeah, we can do Git. Sure. Let's do that for everybody. Everybody else seems to be doing it. Again, they have their own triggers that do cloud build jobs. That's their CI/CD engine. Works with their IAM, cloud logging, cloud monitoring, everything inside Google. You push, and then cloud build, does the test, does the deployment. They can deploy it to services, App Engine, Cloud Run, whatever you want. It's useful for small shops because the free tier is generous. You get a lot of cloud build minutes per month for free, which means a small team can often run entirely free. They've got tight integration with all the other GCP services, of course, because this is a core to the Google Cloud platform. It's simple, lightweight, not a whole lot of extra bells and whistles. Like I said, GCP, they just took Git repos and said, let's hook this into our infrastructure. And bingo bango, we're good to go. You got up to 50 gigs of storage per month. You've got a lot of network transfer per month. You've got 5 users for free per month. There's a generous amount of build minutes. Let's talk about some of the quick implications. If your team's got less than 5 people and you keep your repo size modest, under 50 gigs, you're likely to pay nothing. If you're mid, you might stay within the 2,500 build minutes per month in cloud build for a while. Once you get bigger, though, you're starting to use bigger machines, more users, or a lot of data transfer. The cost can really start to scale, like exponentially. So you got to be really careful about how you're using those runners and how you're using those minutes. Finally, Azure DevOps, then we'll get out of the boring part here. They're simply Azure repos, Git-based repositories with unlimited private, comes with bundled with the other Azure DevOps tools like boards, pipelines, artifacts, test plans, the whole thing. In CI/CD, again, they all have triggers. How this gets triggered to be able to push the code to your servers. Deep ties into Azure Active Directory for identity, plus the rest of the Azure services. Their pipelines are all YAML based, which makes them nice and simple. You push, the pipeline runs, it builds and tests and deploys to Azure services. Useful for small shops, especially if you're all in the Microsoft platform. They've got unlimited private repos, 5 for users, generous amount of pipeline minutes. It's great if you're already in their ecosystem. And of course, since it's Microsoft, if you go up to those enterprise grade features, they're really strong and really robust. They handle everything. Here's the plans, basic fees, some of the repository information, the pipeline minutes, the artifact information, some of the other features that Azure DevOps offers you. Again, I'm just trying to keep this under time. AWS code commit, reliable, no frills, ideal if you're already in AWS. Google Cloud, use it if you're all in on Google. Azure repos, use it if you're all in on Microsoft. All really robust, all really feature rich. Some of them are more complicated than others, but anything is easy to figure out. By the way, and this is one of the things that I was saying at CF Summit, deployment pipelines aren't limited to these big cloud providers or big repo systems. Many of the CF Summit sponsors that were at CF Summit Vega can also assist in setting up these deployment pipelines for your hosted infrastructure. So if you're on XByte or you're on Vivio or you're on Media 3, talk to them. They will happily try to help you set up a deployment pipeline so that you can develop locally, push your code to your repo, and it automatically deploys to your production server. All right, let's talk about environments for a moment. Planes are not repaired in midair. This is why you shouldn't be doing coding against prod. Prod is not the test lab. You should be doing this stuff on a local server, because the goal when doing deployments is safe, boring, repeatable releases, right? Something that you can push a button and know it's just going to work. Here's the absolute minimum setup. Say it's just you, or it's you and one other dev. You've got a local build and test environment. So you're doing your coding on your laptop or your desktop computer, chugging away there. You push code to the repo. And it doesn't matter what repo that is. Could be any of the ones that we've talked about, or any of the cloud providers that will support it. That's going to trigger a deployment pipeline, and that pipeline gets deployed in prod. Absolute bare minimum. Now, these developers who are working locally, whether it's you, someone else, you should mirror production as close as possible. It should be the same web server, same database server, same Cold Fusion server, including the version. If you're on an older version of Cold Fusion, check CFML repo for some of the older versions to be able to get the installers. Install that Cold Fusion Developer Edition locally. It's free, doesn't take up a lot of resources. Or you can run Ortus's command box to be able to set up your local environment. You can use the Adobe Cold Fusion Docker images. They've got Docker images for 21, 23, and 25. Install your database server locally. Maybe the database is run remotely or over a VPN. If you want, use a sanitized copy of your production database to develop against. And then let's talk about some of these deployment strategies, or really how to ship your code to your servers the proper way. Assume you've got 1 or 2 developers. You've got a small application. So let's set up a repository here. And we're going to set up a couple branches. We're going to create one branch called production. Developers are building and testing locally, right? So we've got 2 developers. So developer 1 is working on feature 1, developer 2 is working on feature 2. Features get merged to production, and that triggers a deployment that goes live. Great. So the first developer finishes his feature. That's all done, ready to go. It gets merged to production. That code is now live. He can start working on feature 3. But there was a problem with his first feature. So he's going to create a hotfix branch. When they create that hotfix branch, then, when you think about your infrastructure for a moment, say you've got your web server. Maybe it's a single server. Maybe it's hosting the website and the database all on one machine. You've got a single point of failure. So it's better to divvy those up a little bit. Let's add another database server. So you've got your web server, you've got your database server. Obviously, this is going to come at more cost, but it adds a little bit more protection if you've got a separate web server and database server. More secure, a little bit more cost, single point of failure for each, right? Going back to our developers who are working away, let's say that first developer knocks out that hotfix. Great. And we've started to categorize these. Now we've got a folder with all the features in one folder, the hotfixes in another folder. And those are getting merged into production, getting pushed out to the live server. Say that first developer knocks out feature 3. He starts working on feature 4, knocks out feature 4, starts working on feature 5. It's usually at this point that I start looking at developer 2 and say, why is feature 2 taking so long? You've got this other guy that's knocked out 3 or 4 features by this point. So he rushes in and finishes off feature 2. Great. Now you've got a growing application with different branches that are pushing to production whenever it gets merged into it. He starts working on feature 6. But there's a problem. Because he rushed feature 2, and when I got after his ass and said, hey, get this done, there's all sorts of hotfix problems with it. So now he's got a bunch of things that he needs to take care of. And at this point, I'm starting to think, okay, maybe pushing to production directly is not the best idea. So we're going to create a staging environment, and we're going to add another developer here because obviously developer 2 kind of sucks. So quick note about staging environments. Your staging environment can be on your production server. It doesn't require its own server. It can, doesn't mean it should. Having your staging environment co-hosted on a production server, it just introduces more risk to the live platform. Should be its own server. Should is a very, very, very evil word. Maybe it's not as powerful as your production server, but it should be isolated and configured exactly the same. So now you've got your web server, your database server. We're going to put another server in there. We're going to add a dev server. Great. So now we've got our separate production web server and database server. We've got our dev server handling all the staging. It's more secure, of course, comes at more cost, but it does keep devs from taking down the production server. Let's go back to our story here. Now developers are merging only to staging to be able to do that testing right before it hits production. That way, you're not causing errors in production nearly as quickly, right? So developers are no longer merging to production. They're only merging to staging. Let's add another folder there, and we've got production, staging, development. We've got our features under the features. We've got our hotfixes under the hotfixes. Only staging merges to prod, and only after full regression testing. Now, this is adding a lot more procedure, a lot more overhead to this. Lot is a very subjective word there. This actually isn't that bad. Like I said, any level of process that you add to deploying your code is going to take a little bit more time. But the effectiveness of that, the fact that you're not pushing bugs, is what's going to help out tremendously. When staging gets merged to prod, it triggers the deployment. Now we've got a version under our staging. We've fixed a bunch of features, and our staging environment now has a version: major, minor, hotfix. So I like to create a new one called next release, and everything that we're working on ends up going into the staging server as next release. So say that our developer fixes out all those hotfixes, and now we can take that next release and create it as a version. Now we've got a snapshotted version of the code at a certain point in time. And you can say, okay, this is version 1.0.1. That gets pushed out to production. And then I'm going to create a new next release branch. So now some of the other features are going to get merged into that next release branch. They got knocked out. Now we've got another version, 1.1.1, because those are minor features. Now we've got a successful application that can support multiple developers pushing to multiple stages and not taking down production. So again, let's talk about infrastructure just for a second. We started off with a single web server. We added a database server. At this point, maybe you're thinking we need to diversify that a little bit. So we're going to add our dev server. Let's add a second database server. So that way we've got, some redundancy. If something goes down, maybe it's an automatic failover, maybe it's replication, doesn't matter. Maybe it's hosted in a completely different zone. So that way, if there is a failure, it doesn't take down your whole system. But we've still only got one web server. Let's add a few more. So now I've got 3 web servers sitting behind a load balancer. Traffic comes into the load balancer. Load balancer says which of these servers has the least amount of traffic on it, and it automatically just fires that off. Redis is over there on the side as a small server just to act as session management, especially in Cold Fusion. Say a user's on server 1 and they get bounced over to server 3. The session is stored in Redis on an external server, so that way they don't even know the difference. But maybe you don't want to have the budget assigned for 3 separate servers. Okay. This is when you can introduce something called an auto scaling group. Auto scaling groups will spin up and down servers as you need them, as long as your infrastructure supports. I'm going to take the code and I'm going to deploy it to this server. There was one client that I was working with last year on Black Friday, and they had an auto scaling group that was 2 servers. And on Black Friday, as the traffic started to hit, we watched the auto scaling group and it went from 2 servers to 4 to 9 to 17. They peaked out at 23 servers running the application all at once to be able to handle the load of the Black Friday sales traffic. They did the best sales that they had ever done. And then by the end of the day, as the traffic started to wane, the auto scaling group just started destroying servers, saying, okay, we don't need 23 servers anymore. Let's go back down to 8. Let's go back down to 4, so on and so forth. Some of the do's and don'ts when it comes to this sort of stuff: definitely use a pipeline to push code to your servers. Don't SSH into servers or alter code or FTP files directly. Definitely use different sanitized databases for each environment. Don't use one database for everything. Sanitize those snapshots. Don't use prod data in your dev environment or your local environment. Some other things you might want to consider. These are things to consider if you're feeling a little fancy. Use cfconfig for your admin settings. It's really easy. You just go cfconfig, export to the file. And that way you can set up that configuration to be used on any other server, whether that's a production server or a dev server. There's a group called 12factor.net that has an app methodology called the 12-factor app methodology. One of the things that they consider in there is configuring, do all the configuration as environment variables. Sorry, I accidentally hit the wrong thing there. It's really good to at least give that a look over. Again, it's a lot of procedure, but there are some golden nuggets in there that can help you out. Try using feature flags for safer rollouts if you can afford building them in. Something that you can just set a flag and say, I'm going to turn this on. And if it dies, then we're just going to turn it right back off again. Remember that your Docker containers are cattle. They're not pets. They're not meant to be long-lived, or, the moment you start saying, well, I don't want to destroy that Docker container, you're not really using it well. For safe data across environments, remember you've got a golden production snapshot that should be encrypted. It should only be available via the VPC or a VPN. Your staging data should be derived from that production snapshot, but all the personally identifiable information should be masked or redacted or something. Your local seed should have false small fixtures in Git. Don't ever store copies of the database in your repo. For code promotion flow, this is one of the things that that I recommend, is that if it passes the local test on the developer's computer, it becomes a pull request. Another developer takes a look at that pull request and says, okay, yeah, you're not sending credit card numbers to yourself. Let's push it to staging. Maybe a third person or somebody else, QA, UAT, they look at the staging server and they say, okay, this looks good. Let's push it to the release candidate. Then they just give it one more pass and then it gets launched. Again, that's a lot of overhead, a lot of flow, especially when you're a 1 or 2 man shop. You don't want to, you don't have the capability to be able to have multiple people reviewing this code. So this is probably more robust than most people need, but it is still a good idea to kind of move towards. Some Cold Fusion friendly practices. Dockerize your ACF environments. Again, they have Docker containers for the last 3 versions. Use that cfconfig command that I talked about to synchronize all your administrator settings. Use the logs. I don't know how many times I have to repeat this to people. So just log some stuff. I know it's a pain in the ass to have to go into the administrator or go, sync to the server and get the files, and logs are notoriously hard to read, but use them. It can do a lot of fixing for you. For the application CFC, read that stuff from the environment variables. For example, if you've got your data source set up in your application CFC, you can see here on the bottom 2 lines, I have environment variables set up that have the username and the password rather than storing that in the repo itself. Here's a quick Docker Compose example. This is all you need to set up a Cold Fusion server and SQL server locally on your machine. You run Docker, it'll spin up those 2 containers. Probably need a network to be able to connect them, but really simple example. cfsummit.vegas is the website where I've put all of these files, and there is also a lot of examples on there. So I have pipeline examples for pushing AWS to AWS, or GitHub to AWS, or GitLab to AWS, or Bitbucket to AWS. Repeat that for all of the cloud platforms. There's also this presentation. If you missed something and want to see it, I've got it in PDF format and the keynote. And that's it. I did see some questions in the chat, so I'm going to kind of sneak up and see what you got here. You can also use staging to independently test a hotfix before merging it in your pipeline configured properly. Absolutely correct, Dave. And that's a really good idea. The more barriers that you can put into place to avoid bugs from going out to production, the better. What do you recommend for setting up regression testing if there's none currently in place? So for regression testing, if you've got your code already in a repo, and that repo is pushing to a production server, create a separate website, regression.mycompany.com, that runs the code that's about to be pushed to production. And again, I do recommend that that's on a separate server, but it doesn't have to be. You can do it on the same server, as long as you're smart enough and know that, hey, we're running a second copy of the application on the same web server, and if we push something that's going to take the whole thing down, then it's going to take the whole thing down. Any unit testing framework available for Cold Fusion? There are several. If you check out the Ortus tools that are available, they have TestBox, which is baked in testing for any type of cold box application. There are several other frameworks out there for testing, so on and so forth. But really, the best tests that I've seen are you build your own. You know how the application is supposed to work. But you also know that, the QA person is going to come in and try and use this completely differently than you had designed it for. So just be prepared for that. Write your own where you're just saying, hey, if I fire this, this is what I expect to see on the page. Does that pass? Yes or no? Dan recommending TestBox. Yep. How do you create multiple profiles for different environments with a different set of variables for each environment? Great question. So environment files are .env files. I have seen some applications where the application.cfc or something in the server is configured that if the website that I'm hitting is beta whatever, then use the dev.environment. If it's just this, use the production environment. Sometimes I've seen companies that just manually manage their environment files separately. I don't really recommend it. And they say, don't push the environment files. We're going to create the environment file on the dev environment, and that one's going to stay. Here's your environment file for your local environment, and never overwrite it. There's a lot of different methodologies on ways that you can do that. Right now, we're using it from database parameters. There must be a better way. Yeah, of course there is. Look up .env files. .env files are really helpful. What tools do you recommend for sanitizing production data masking PII for the dev environment? I haven't used a tool to be able to do that, quite honestly. I've created scripts for different companies that go through and replace all the update first name equals John, last name equals Doe, when they do pulls from the live data. A lot of it that I've done is just complex scripts that erase all of that stuff because you know what's needed and what's not. Or you just don't export, if you've got one table that's all social security numbers, don't export that table. Create a blank table in your dev environment and pre-populate it with some bogus data that matches all your user records. We store our environment variables in our database for each environment. Just looking for more questions over here. And then in the Q&A, I'm seeing we have Azure DevOps and GitHub. We're using GitHub for version control and branching. What's the best practice for using Azure DevOps and GitHub? We don't want the teams to duplicate the use of tools. What's the recommendation? My recommendation is that you continue using GitHub as your repository and you build a pipeline between GitHub and Azure DevOps. Again, if you look at that website I just sent, cfsummit.vegas, it will have an example in there on how you can do that. Just go into the examples, look at the ones for Azure and find the one that's GitHub to Azure, and that'll at least get you started. But once you set up that pipeline in GitHub, it can push to whatever Azure resources you want. Any other questions? Nope, I see no other questions here. All right, I do have a $50 gift card to be able to give away. And I did say to Apurva beforehand that I was going to give it to the first person to ask a relevant question. And that looks like Rob 22. What do you recommend for setting up regression testing if there's none currently in place? So Rob, congratulations. You get a $50 gift card for Amazon. What's it, Apurva, what's it, the gift card from?
It's an Amazon gift card.
Amazon. Okay, cool. Any other questions? All right. Well, my email address is david@CodeMonkey I love talking and working about this sort of stuff. And I really do mean it when I say it's a privilege to present for the Cold Fusion community. I love this community. I love this programming language. I love everything that, we have going on with it. And I'm happy to talk about this stuff or just shoot the shit or whatever. So yeah, please send me an email. I'm happy to talk about it. And if there are no other questions, I'll just double check the chat. Nope, we're good to go. Thank you all.
Thank you, David. It was a wonderful session. Thank you for joining us today.